So our first panelist is Dr. Lee Clapp of the Institute for Sustainable Energy and Environment. He and his team have launched an air quality study in our region to monitor the air quality effects, such as volatile organic compounds that come from oil and gas activity. So, Dr. Lee Clapp.
Thank you. It's a pleasure to be here. Can everybody hear me okay? I'll try to keep this brief as my fellow panelists here are more qualified than I am, but I'll give you an introduction to some of our air quality monitoring at Texas A&M Kingsville. And I should acknowledge some of my colleagues. Dr. Alvaro Martinez is really our air monitoring guru. He couldn't be here today. He's actually the person in charge of air quality monitoring for the city of Corpus Christi, which is a near non-attainment city. So the Barnett Shale, close somewhere between 7,000 and 10,000 wells in the Barnett Shale, and I guess next one. And one of the big issues with oil and gas operations is the air pollution issues, and pollutants from oil and gas drilling sites include VOCs, or volatile organic chemicals, which primarily come from the condensate tanks, and nitrous oxides, which primarily come from internal combustion engines. And when those combine in the presence of sunlight, they produce ground-level ozone, which has health impacts. Here's ground-level ozone. And next. And in the Barnett Shale, I won't go through all these slides, but the total ozone precursors, ozone and NOx, from the oil and gas drilling operations in the Dallas-Fort Worth area, which is shown here, 273 tons per day. This is the mobile sources. This is all the oil and gas operations. So you can see that all the oil and gas operations in the Dallas-Fort Worth non-attainment area is actually a little bit greater than all the on-road mobile sources. So it's a significant source of ozone precursors. Next. And if you break down the sources of those emissions, the primary source is the condensate tanks, oil tanks, shown here in orange. And these are the tanks where the condensate goes, and they release vapors periodically. This is a big opportunity if we can install vapor recovery units. We really reduce this significantly. The other one is the compressor engines, where all of the internal combustion engines produce nitrous oxides, and again, those combine to produce ozone. And just comparing the expected projections for the Eagle Ford versus the Barnett Shale, the x-axis are time and the y-axis is billion cubic feet per day, and you can see that it's pretty comparable between what's expected for the Eagle Ford and what's been seen up in the Barnett Shale. Next. And you'll probably, I'm sure you'll see better images of this, but this is the Eagle Ford formation from down from Laredo all the way up south of San Antonio. And the biggest concern with the ozone is really in San Antonio. San Antonio is a near non-attainment city, and they're really concerned that the VOCs and NOx from the Eagle Ford development is going to affect and push them over the limit for ozone non-attainment. And this is just showing, if you look, this is San Antonio's ozone parts per billion levels over time. And this 75 parts per billion is the federal standard for the National Ambient Air Quality Standard for ozone. You can see they're just barely in attainment now. And it's expected that EPA is going to lower this limit down to 70 or 65 ppb in the next year or two. So San Antonio is really worried that the emissions of VOCs and ozone from the Eagle Ford is going to push them over the limit for ozone non-attainment. Yeah, these just the expected federal limits for ozone that are expected in the next couple of years. And At Texas A&M, we've been monitoring ozone and NOx, VOCs, for the city of Corpus Christi, which is also a near non-attainment city. We monitor ozone, ozone precursors, NOx, and VOCs. We also monitor ultrafine particles, or PM 2.5, as well as meteorological parameters, wind speed, relative humidity, wind direction. And we actually operate, at University of Texas A&M Kingsville, we operate 4 continuous air monitoring stations around Corpus Christi. TCQ operates the other 2. I guess next. And this is what our continuous air monitoring stations look like. They're a small trailer or to a shed, and we have 4 of those around Corpus Christi. Next. And things we monitor include wind speed, relative humidity. Next. As well as VOCs. This is a gas chromatograph. We use SUMA canisters to collect air samples, take them back to the lab and measure the VOC concentrations. We also monitor ozone continuously. I guess my NOx monitor disappeared. And so we have experience monitoring those parameters continuously. Next. One of the issues for oil and gas monitoring air emissions from oil and gas operations is they're very dispersed. They're not like a refinery where you can set up a shed and monitor concentrations. So one of the things we're looking at is using wireless network systems with sensors, putting some sensors around the perimeter of a site and feeding the data back through telemetry back to the campus so we can monitor it continuously. David Burnett's put us in contact with Oak Ridge National Lab, and they have this Sensipedia site where you can send data back, and it's like basically like Facebook for environmental sensors. Next. And this is some of Dr. Martinez's ozone monitoring for the city of Corpus Christi. You can see that when it's above 70 here is when we're out of attainment, and Corpus Christi is right down here. And I guess you can go to the next slide. And he also monitors or does modeling. Well, this is a large regional map, and you can see San Antonio and Corpus Christi, and you can see over time the development of ozone concentrations. And we'd like to do something like that for the Eagle Ford shale development. Again, it's a much more difficult problem to manage because it's such more dispersed sources. Next. And then finally, we like to take that meteorological data, the concentration data, and put that into regional models like you saw before. And this again is Dr. Martinez's work, and predict the impacts and also come up with strategies to reduce the impacts of air emissions in Eagle Ford shale. And then finally, once you have a good model, next you can come up with risk management, risk assessment strategies, and try to figure out where can you reduce emissions most effectively for the lowest cost. And things like vapor recovery. There's some ideas of perhaps using electrical motors instead of diesel motors in certain strategic points. And I guess with that I'll finish up. I'll try to leave more time for the rest of the panelists. And I guess that's it. Thank you very much.